Welcome back to the part 2. We are going to study hypothesis testing with small samples. This includes t-test. The learning objectives. After this lecture, the viewers would be able to understand the testing procedure based on the t-test, would be able to perform the testing of the hypothesis on the population mean for small samples. You would be able to carry out numerical calculations for problems of this type. The 5-step testing procedure. Step 1. Prepare the statements for null hypothesis denoted by capital H and alternate hypothesis denoted by K. For example, H is mu equal to mu suffix 0. The alternate can be any one of K is mu less than mu suffix 0 or K is mu is not equal to mu 0 or K is mu greater than mu 0. Step 2. Decide the test statistic. If the population standard deviation is known, you compute this ratio is called Z. There is a numerator denominator. Numerator there is a quantity x bar minus mu 0, denominator sigma by square root of n. This has standard normal distribution with the mean 0 and 1. If sigma is unknown, you will use instead this result t equal to x bar minus mu 0 divided by s divided by square root of n. This has students t distribution with the degrees of freedom nu equal to n minus 1. The important requirements is that the sample must have come from a normal distribution. These are important and restrictive condition. The critical region must be defined as in step 4. This is an interval or union of intervals that depends on k. The distribution of the standardized test statistic Z and the corresponding rejection region for each form of the alternative hypothesis, that is left tailed, right tailed or two tailed, will be described. For the k sigma is known, we have done a picture. If the alternate hypothesis k is less than type, you can see that there is a line given in red color. This is the critical region. Over this interval under the curve, the probability is alpha or the area is alpha. In probability theory, we use interchangeably using probability as well as integration. For the k sigma is known, we have drawn the normal curve. If the alternate hypothesis k is greater than type, the critical region is on the right hand side shown as in red color. The area above the straight line and under the curve is alpha, that is it is the probability of alpha or area under the curve alpha. For the k sigma is known, if the alternate hypothesis k is not equal to type, then the critical region includes both the right end and the left end of the line shown in red color. This one, you can see that on both of these there is a area under the curve is alpha bit 2 here, this is alpha bit 2, therefore, the total area is alpha. The limits on the boundary of these regions are given in the following table. There are 2 rows, first row is for alpha equal to 0.05, second row is 0.01. There are 1, 2, 3 columns, first column for two tailed test, that is not equal to type. Then the critical region is outside of this interval minus 1.96 to 1.96 outside this interval. For 1%, this is the interval, the point should lie out of this interval to get rejected. One tailed test, right tailed test means the value is greater than 1.645. When you are having left tail test, the value must be smaller than minus 1.645. Similarly, for 1% case. For the case sigma is unknown, the distribution of the test statistics t and the corresponding rejection region for each form of the alternate hypothesis, that is left tailed, right tailed or two tailed, will be described. We have drawn the t curve is almost similar to normal distribution except for some flatness on edges. The critical region for the alternate hypothesis k mu less than mu 0 is the line shown in red color. Notation that line ends with minus t alpha. Here this t alpha depends on the degrees of freedom, that is not clearly shown here. to avoid confusion. So, this point has the probability under the curve over this line is equal to alpha. For the alternate mu greater than mu 0, the critical region for the alternate k is mu greater than mu 0 is the line shown in red color. Here the starting point is T alpha and the area under the curve from the T alpha to right hand side is alpha. So, we say the area under the curve over T alpha comma plus infinity has area equal to alpha. Please note that T alpha is not just a number, it will depend upon the degrees of freedom nu, that is not shown here to avoid confusion. We will have by symmetry minus T alpha equal to 1 minus T alpha, because you can see that the curve is symmetric, whatever you find here you can find the same value on left hand side. So, the relationship is minus T alpha equal to T 1 minus alpha. When alternate hypothesis is not equal to type, the critical region is shown in red color, this one and this one. Notation T alpha by 2 is marked here. So, interval from minus infinity to minus T alpha by 2 and T alpha by 2 to E plus infinity, 2 intervals are considered for rejecting the null hypothesis. Because we want to have only total value alpha, this area is given to be alpha by 2, the right side tail area is alpha by 2. So, total area is alpha. Solved problems. Problem number 1. The price of a popular tennis ball at a national chain store is rupees 179. A person bought 5 such balls at an online auction site for the following prices in rupees 155, 179, 175, again 175 and 161. Assuming that the auction prices of balls are normally distributed, determine whether there is sufficient evidence in the sample at 5% level of significance to conclude that the average price of the balls is less than rupees 179 if purchased at an online auction. Solution. Since the sample size is only 5, we have small sample. The null hypothesis is H is mu equal to 179 and the alternative is k is mu less than 179. Please note that in the problem it is suspected that the online price is lesser. So, that dictates the type of alternate hypothesis, that is less than type. We shall fix the value for alpha as 0.05. The test statistics is t equal to x bar minus mu 0 divided by small s divided by root n, which has students t distribution with nu equal to 5 minus 1 equal to 4 degrees of freedom. The mean and standard deviation of sample values are computed as x bar equal to 169 and s equal to 10.39. Inserting the values into the formula, we get minus 2.152. From table available from standard textbooks of tail areas of students t distribution, we find minus t suffix 0.05 equal to minus 2.132. Since the value t value is less than minus 2.132, we reject the null hypothesis. Now, we will conclude according to the given problem. The data provides sufficient evidence at 5% level of significance to conclude that the average price of such balls purchased at online auctions is less than rupees 179. Problem number 2. A production of an item is found to be profitable if its weight is greater than 0.5 gram. 6 items are found to have weights in gram 0.45, 0.49 and so on. The question is, do the weight of 6 items present evidence to indicate that the average weight of these items is in excess of 0.5. Solution. The null hypothesis is H mu equal to 0.5, the alternate hypothesis is k mu greater than 0.5, the critical region is at the right tail. To find the critical region, we fix alpha equal to 0.05. From the table of t values, we get t suffix 0.05 equal to 2.015. Therefore, the critical region is interval starting from 2.015 up to infinity. We compute the mean and standard deviation of the sample I am not going to discuss everything. The calculated value is x bar equal to 0.53, sum of squares of deviations is 0.0156. This you can, the students can use it to check this result. The variance is sigma x I minus x bar square divided by 6 minus 1, that is 0.03. The standard deviation is square root, that is 0.055. The value of the critical ratio is computed as t equal to 1.3155. Since the value of test statistics does not fall in the critical region, that is interval starting from 2.015, we do not reject the null hypothesis, that is no evidence for the statement that the weight exceeds 0.50. Summary: the critical region for various alternate hypotheses are indicated. The test procedure for the small sample is explained. Some numerical problems were solved to understand the procedure. We have come to the end of this part. Let us continue in the next video. Thank you.